Yeah, very good morning, everyone.
Good morning, sir.
Good morning. So we will wait for 1 minute so that someone will join, and then we will start our session. So let's start our session. Okay. So previously, in the previous week, we will discuss about the quantizing and the quantizational different kind of sample operation, right? So it's supposed to be the periodic sample, multiple order sample, multiple rate sample, and the random sample. This such kind of different type of sampling operation that we will discuss in the previous week. Okay, so even we will also discuss what the quantizing is. So today we will discuss about the what the quantizing level, okay, and as well as what will be the quantizational error which will be signified. Okay, that means in a full scale range, and we have considering the most significant bit and as well as the least significant bit. So depending upon the different kind of bit operation, we have to consider some input, okay, for the quantizational or the for the quantizing of a particular number system. Okay, so okay, so we will directly go to share my screen so that so is my screen is visible? Yes.
Yes, sir.
Okay, fine.
Yes, sir.
Fine. So in the previous day, we will discuss about this thing, different kind of sampling signals of the sampling operation supposed to be the periodic signal, the multiple order sample, multiple rate sample, and the random sample, right? So we will also discuss the what the quantizing and the quantizational error. That will not be discussed. So today we will discuss the quantizational error. Okay, so what the quantizing is? Quantizing for the conversion process from the analog to digital. What are the main function that we will also been discuss? There will be the three function. One is a sampling, another one is the amplitude quantizing, and the third one is a coding. Okay, so we will discuss already what the sampling is, what the amplitude quantizing is, and what the coding is, right? In the previous lecture, right? So today we will discuss about little bit about the quantizing, more thing about the quantizing. Okay, so we will discuss more about the quantizing and as well as the quantizational error, right? So what will be the based on the t value, that means the periodic, the period, the time period, and the quantizing, that two things will be very much important for the digital control system, right? That is very much important. Okay, so today we will discuss about the two things. Okay, So today we will discuss about the little bit portion of quantizing, right? And we will discuss about the quantizing error. Okay, so these are the two things we will discuss today, right? So first we have to discuss a few things. We will already discuss about the what the quantizing is. So first we have to know about the quantizing. Okay, so quantizing, so if we considered a standard number system, okay, so if I consider the standard number system that will be used for processing the digital signals, okay, in is a binary number system. So whatever the standard number system we are used for processing any such kind of digital signal, that should be your binary number system. Yes, that should be your binary number system, right? So, what we can say that the standard number system, in case of a quantizing, the standard number system, the standard number system used for processing the digital signal, processing the digital signal. That is actually that is the binary number system. Okay, binary number system. So anyone heard about the number system, standard number system in the digital electronics? Number system पढ़े हो? Hello, anyone? Rahul?
Yes, sir. Number system.
हाँ, number system क्या है? What the number system is? The standard number system बोलने से क्या? What the thing is that? The standard number system in the digital electronics. That means if we consider the digital electronics, the number system will be based on either on one or zero. Okay, that means you have in the digital electronics you have a conversion from the octadecimal to hexadecimal. You will convert to this thing. यही तुम लोग किए हो ना? Octadecimal to hexadecimal, right? Right ना?
Yes, sir.
Okay, so this kind of number system, so a simple number system which can be used for processing any such kind of digital signal. Digital signal is actually nothing but a number system that will be inserted into a particular digital controller or the digital computer, and from the digital computer, depending upon the whatever the number system you are giving to the particular system, so that thing, that particular digital computer will be giving the output, okay, in a discrete form, right? So that is the thing. So there must have a simple or the standard number system that should be implemented in the any such kind of digital signals. Okay, so that is actually known as that number system, actually the binary number system, right? So in a such a system, if I consider a code group, suppose the binary system is actually what it depends upon each and every individual code. Okay, so in a system, a code that will be group of consist of a n number of paths. Okay, so what we can say that if we can say if in a system, if in a system if in a system the code group we can say which will be consist of n paths. Okay, keep in mind these things, n paths. Okay, n number of paths, and each pulse will indicate each pulse that will indicate what, either, that means whatever the pulse we are getting from the input, okay, that should be the n number of input, because in the input we have not only the single input we are giving, okay, so we are have a n number of input. So due to this n number of input we are getting the n number of pulse, okay. So each pulse which will be getting from the input, that will be indicated either in an off state or either in an on state, right? So it should be either in on state, okay, either in on state, right, or in a on state we will considering it is 1, okay, or we can say that it's a off state, right, off state, and off state we will consider as a, sorry, 0. Okay, so that is the thing. So what we will say, if we are considering any such kind of system having a code book which will be consist of a n number of pulse, and each pulse which will be indicated either in a off state or either in a on state. That means if it will be if any input will be 1, that should be in a on state, and if the input will be your 0, that will be in a off state. Okay, whatever the binary number system will be considered in the input, right? So in this case, okay, so if I consider, so in this case of quantizing, in this case of quantizing, we will consider n as a on off state, we will consider n as a on off pulse, sorry, not state, on off pulse, okay, that can be represent represent like a 2 to the power n, okay, amplitude, 2 to the power n amplitude levels, or we can say that it should be the output state of a particular system, right? So the output state of a particular system. So what we will consider, if we have a system having a code group of which will consist of a n number of pulse, and each pulse that will indicate either in a on state or in a off state, okay. So in this particular cases of the quantizing, n we will consider as a on off pulse, okay, on off pulse, and that can be represent, that particular quantizing effect that can be represented at a 2 to the power n amplitude level, or we can say that 2 to the power n output state, okay. So in this case of a sampling or the amplitude quantizing or such kind of coding, okay, so these are the three things which will be available for the conversion of the analog to digital converter, okay. First one, when I already told you in the previous class, that the sampling, amplitude quantizing, and the coding, that will be the natural phenomena for the conversion of analog to digital conversion, okay. So for that cases, and these are the three things will be, so these things we will already been discussed, the sampling, amplitude quantizing, and the coding. That thing will be the main major function for the conversion process of a analog to digital conversion, as well as, and this particular process will be only been considered, this three process is only been considered, okay, I will okay, so this three process is only been considered only we have a binary number system, right? Only we have a binary number system, right? Or we have a simple representation of a number system, right? So for that cases, what we will see that the quantizing level, okay. So the important term which will also be signified, the quantizing level, the quantizing level, which will be defined as a capital Q, okay, is defined as the range, as the range between two adjacent A D J A C E N T, sorry, huh. two adjacent decision point, two adjacent decision points, and that particular quantizing level will be given as, and it given by how? It's given by the capital Q is equals to FSR divided by 2 to the power n, right? Where Q is actually nothing but a quantizational level. FSR, where we can say that Q is your quantizing level, right? FSR is actually nothing but a full scale range, full scale range. Okay, and 2 to the power n is actually, I told you in the previous thing, it will be that this particular quantizing, the process that will be simplified, that will be represented by a 2 to the power n, okay, amplitude level. So the quantizing level, that will be very important. The quantizing level, it should be defined as the range between the two adjacent decision points, and it's given by q is equals to fsr divided by 2 to the power n, where q is actually considered as a quantizational level and fsr is a full scale range. Okay, so what do you mean by the two adjacent decision point? Okay, so two adjacent decision points means, suppose we have a binary number system. Suppose I give you some example, right? So if I will consider a simple number system having a on and off state, a number sample, okay, supposed to be क्या ले सकते हैं, supposed to be considered as 1 0 1 0 0 0 1. Okay, so this particular level, so if I consider these things in a particular block, in a particular block so if I consider this thing, okay, so this is actually a nothing but a binary code which will be the input of a particular system. Okay, so if I will consider this is supposed to be, we have a 2 to the power n amplitude level, we have a 2 to the power n amplitude level. So if I will consider, supposed to be this is your 2 to the power 0, this is 2 to the power 1, this is 2 to the power 2, this is 2 to the power 3, 2 to the power 4, 2 to the power 5. Okay, so 2 to the power 6, 2 to the power 7, and dot 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 n number of. Okay, supposed to be, it should be the 2 to the power n number of. Here also we can add something, right? So 2 to the power n. So if I consider up to the 2 to the power 7, so this particular portion is actually called your MSB. Okay, this things is already I will discuss. MSB, it's called the most significant bit. Okay, and this part is actually called your LSB, is your least significant bit. Okay, so for that cases, if we will consider the quantization level q, and that should be defined at a particular range between the two adjacent decision point. Okay, and that should be given by the, and for that cases where FSR divided by 2 to the power n, FSR I will told you that it's a full scale range, right? So noted that you will consider it as a note that, okay, note that key, the leftmost bit, okay, the leftmost bit of a natural binary code has the most weight, and it is called the most significant bit. Okay, keep remind these things, why it is called the MSB. For that, the left significant bit, so this will be is your left side. Okay, so this will be your left side, right? So in this cases, the leftmost the leftmost bit of the natural NATU, a natural binary code. Okay, so this is actually your natural binary code. Okay, and the leftmost bit is your one, right? So the leftmost bit of a natural binary code has the most weight. Most weight. Okay, most weight means what? Most weight is means it this particular code, having a one half, one half of the full scale, one half of the full scale, right? Full scale, and it is called the most significant bit, or it should be called the MSB, most significant bit, right? And and least significant bit, LSB. So this will be the extreme right, right? So the least significant bit is what? The rightmost. This is your LSB, right? The rightmost bit has a least weight. This will be the most weight. That means whatever the input, whatever the code we are assigning for a particular system, that particular MSB will be considered as a most weight. That means one half of its full scale. Okay, that will be occupied. Okay, and that will be called your most significant bit. And in case of a LSB, the rightmost bit has a least weight. Okay, has a least weight, supposed to be 1 2 to the power n. Okay, 1 divided by 2 to the power n times, 2 to the power n times of the full scale, of the full scale, right? Full scale, and it is called, the least significant bit, the least significant bit, right? Or it can be shown as a LSB, right? So thus we can say that the LSB is actually the FSR divided by 2 to the power n, which will be nothing but a my q. Okay, so this significant bit is actually your quantizational level. So this particular least significant bit will be considered as a this least significant bit will be considered as your least is your quantizational level. Okay, so keep remind these two equation where LSB we can considered as a FSR, that means the full scale rate divided by 2 to the power n, which will be exactly known as your Q. Okay, and the least significant bit, and we can say we can say that the least significant bit is uh, the quantizational level, or the quantization level, and that will be defined as a Q, right? Okay, so is it clear? Is it clear? Okay,
Yes, sir.
so we will consider, keep remind these things, quantizational level that should be defined a range of two adjacent decision points. Suppose this is the one decision point, okay, 2 to the power 7, and this is the another decision point. So it will be this quantizational level will be defined as a range between the two adjacent decision point, which will be considered as a MSB and the LSB, and which will be given by a Q is equal to FSR. This is actually your full scale rate. This will be considered as your FSR, right? Full scale rate divided by whatever the your 2 to the power n. That 2 to the power n is actually your your amplitude level. Okay, so if a particular signal having a MSB and the LSB, least significant bit, and what will be for that particular signal, for that particular beat or code, what will be my amplitude level. Okay, so your quantization level will be defined the full scale rate of a particular code divided by whatever your amplitude level is for a particular system. Okay, so there must have a most significant bit and the least significant bit. Again, I told you the least significant leftmost, this will be the left part. Okay, so the leftmost bit of a natural binary code having a most weight, that means one half of your full scale, that will be considered as a MSB, and it will be called as a most significant bit. Okay, and LSB, that the rightmost, okay, this part. Okay, so the rightmost bit have a least weight, supposed to be it should be 1 by 2 to the power n. So the least weight that times of a full scale, and it will be called as a least significant bit. Okay, and the least significant bit will be considered as your quantizational level. Okay, which will be also known as a your full scale rate divided by 2 to the power n. So we can say that the least significant bit, this is very important, least significant bit is considered as a quantization level, apart from if we will not consider the most significant bit, as it has a mostly weighted, right? So I think you have a class from 11:30, so I'm a little bit late. Okay, so you have a Sangita Dev Burman class, so madam class. So we will stop the session for today. We will again discuss tomorrow. Okay, what the quantization, I think 2 or 3 classes is required for the module 1. Okay, only 2 to 3 class, then we will start the module 2, which will be known as your jet transformation, right? So the jet transformation will be very important part in this digital control system. Okay, you need to understand these things. So only 2 3 class left on this particular module 1, then we will discuss the jet transformation, right? Okay, so we will stop the session for today. We will discuss the few things in the next class. Thank you. So am I stop the session?
Thank you, sir.
Okay.
Thank you, sir.
Okay. So everyone join madam class. We left the session for today. W603.
Okay, sir.